We saw how oversampling improved the performance of logistic regression on a class imbalanced dataset. Now let's implement hybrid sampling using the SMORT algorithm. SMORT algorithm is implemented in DMWR as well as SMORT family package. Both these packages in R has this algorithm implemented. I have loaded up the training and the test data already. So let's start with implementing SMORT directly. What SMORT does is it creates new samples of the minority class that are very similar to the data that is already present in the training data set. It also undersamples the majority class so that ultimately the new dataset has a balance of the majority as well as the minority class. The percentage over and percentage under arguments over here control how much of oversampling and undersampling has to be done on the dataset. Now, approximately you have a comparable proportion of the minority as well as the majority class. Now, let's build the logistic regression model. The model is built. Let's look at McFadden's pseudo R square. This has definitely improved. It was around 40% previously. Now it has gone to 56%. That means 56.8 percentage of the variance in Y has been explained by the model. Let's predict and compute the capture rates for the various deciles. Now, if you look at the capture rates, it has actually degenerated from what we had originally in the model. The first decile originally had captured 56% of all the responders. That is the value of Y where the value is yes. Likewise, the second decile has also gone down slightly. It has gone from 85.2 to 84.3. So even though we had achieved a better McFadden's R square, for practical purposes, this model may not do as good as the original model did perform for us. Now, why I'm making that statement is because if the business wants, whoever is running this model wants to target a certain proportion of population by targeting, say, the first 30% in terms of the probability scores, they will be able to capture 95.2% of the responders. Whereas the original model, you can capture about 96.1. So that is about 1%, almost 1% drop in the capture rate. Let's look at the sensitivity as well. Sensitivity has gone up from 43.75 to 87.71%, which is a major move. The F1 score has also improved. So that means this model is able to correctly classify the responders and non-responders. It is doing well in that sense. However, in terms of the capture rates, the original model is still outperforming. Now, can you imagine why this could happen? That is, the model's sensitivity and F1 score is high, but the capture rates of the model, it is actually underperforming than the original model. What can happen underneath is the probability scores of all the ones are nicely calibrated that all of them are greater than 0.50. As a result, they are being predicted as 1 itself in the hybrid model that we just built, hybrid SMORT based model that we just built. That is the reason why sensitivity and F1 score are good. But why should, the important question is, why should the capture rates go bad? It can go bad when concordance of positive or ones and zeros are not held. That is, the predicted score of zeros is greater than the predicted score of ones. If this happens, then the capture rates can suffer. So let's check the concordance for this model. I'm using the information package to compute concordance. When computing concordance, I have to explicitly transform the y variable as a numeric, and I'm reducing it by -1 so that the predicted values are either zeros or ones. These are the two arguments we are passing to concordance. So the concordance value for this new hybrid model is 93.69. This for sure is lesser than the concordance that we observed for the original model. Since the concordance for the original model is better, even though the hybrid model is having a better sensitivity, better precision, and even better McFadden's pseudo R square, for practical purposes, the original raw logistic regression model without the hybrid sampling is more useful.